Okay, folks, are we ready to get rolling on day 3 here? Are we ready to roll? Okay, have a seat. Have a seat. Opening remarks today. I've got a few things to cover, so it'll be a little bit longer. So the keynote may be not start until about 9:10. But there's some cool stuff I want to cover. So first, as you know, these are being live streamed, so in case somebody tunes into the live stream and they didn't watch day 1 or 2, I'm Lawrence Schwedler. I'm the program director of Digipen's Music and Sound Design programs. I'm the chair of this conference, along with my co-chair, Remi Audfray here. We're so happy to have you here. Welcome. This is day 3 of the conference. And I just wanted to plug my programs because it was one of the reasons when Dr. Edgar Schweri suggested, I think 5 years ago, that we do a conference to increase visibility of Digipen and our program, so I just want to take this opportunity to do it. Digipen's an amazing place. You can probably feel it just from being here, but I run two undergraduate programs in music and sound design. One is a Bachelor of Arts in Music and Sound Design, and it's a unique hybrid interdisciplinary program that includes foundational music studies with audio engineering and particularly with technical sound design, implementation of audio and music for video games. I also oversee the Bachelor of Science in Computer Science and Digital Audio program. That's a 4-year undergraduate degree in computer science. And Digipen also offers, I think, 3 other undergraduate computer science degrees, all of which are quite rigorous and quite foundational, and we're very proud of them. But the secret sauce of Digipen is that all of our programs in computer science, game design, art and animation, and music and sound design are interdisciplinary. So our teams in their sophomore and junior years work on multidisciplinary teams for software development. And so it's not just the technical skills to do their job, but it's the soft skills and the production skills that we all know that to do software development is what is required. And so our students are in that crazy Edison lab upstairs where the posters are. So there's hundreds of students working on multidisciplinary teams. Anyway, that's what Digipen does, so there's my plug. Today's keynote and panel discussion featuring Karlheinz Brandenburg will be, as I said, will be live streamed, and then it, along with days 1 and 2 keynotes and panels, will be posted to the AVAR website. So sometimes we have to clean up audio so that we don't get tagged by YouTube for copyright violations for material well, I won't mention anything about a Dolly Parton tune that got. So once we edit out and mute that video, those will be up and posted. So within a week, if you missed any of the keynotes or panels and you want to watch them again, they will be on the AVAR website. We invite you to join us this evening for an informal mixer at the Black Raven, also affectionately known as the Faculty Annex here at Digipen. It's the brew pub that's just down the block, so if you go out to Willows Road and turn right, you can walk along the bike path on the other side of the road, and it's about an 8-minute walk, and we'll be convening there. The last workshop ends today at 4, so I don't know, I might just race over there to get a cold beer, but if anybody wants to join us, we'll be there. And then the last papers session doesn't end until 6. So that's our little informal gathering for those of you who can join us. I wanted to give a big shout out to Digipen's Director of Operations, Alex Comer, and his amazing team at the Bites Cafe. You might have seen, if you were at our mixer last night, the young gentleman who was lighting the candles on the tables out there and cleaning up trash. That's our Director of Operations, Alex Comer, and he worked with me for a year to put this together, and he's been just instrumental, and his staff, Myrna, who directs the cafe staff. So I'd like a round of applause for the cafe staff and for Alex. Yeah. Woohoo! Thank you. Thank you. I'm a big believer that food and drink are essential to a good conference. Let's see, I've got a couple more things real quick. I'd also like to give a shout out to Dan Mortensen and his amazing crew of Digipen students and volunteers for their outstanding work on audio, video, and streaming of the conference. So here's to Dan. And all of our volunteers in the black shirts, so that's that. Thank you. Finally, I'd like to thank the Audio Engineering Society's Bill Foster, Graham Kirk, Sue Williams, Lori Jackson, Frank Wells, and Corey Walthall for their essential guidance, support, and promotion of the conference. Obviously, this is an AES conference, and those guys were great. They made this happen. Finally, I'd like to invite you all to connect with me via LinkedIn. So you can just give me a LinkedIn connection for those of you who haven't already done so, or via email here at Digipen, because I'd like to stay in touch and don't groan now. I want to start planning AVAR 2024. I really do. So it'll be 2 years from now. And we're going to do it. So I hope you can all partner with us on that. So reach out to me on LinkedIn and connect. And I think we're going to try to do a mailing list, something just to take a little bit more lead time to plan. So it's we've got some really good ideas. I've talked with some of you about what we might have in store. And now I'd like to introduce PAPER's co-chair David Lou-Alon. And Hannes is not here. So I'm going to turn it over to David for a special announcement.
Yay. Hey, everyone. So we wanted to announce on the Best Paper Awards.
You can take your mask off.
Yeah, better this way. So yeah, just to say a few words, there were really amazing papers submitted. So thanks everyone for the contribution. Thanks for the reviewers for the dedicated work. As always, it was really hard to choose. There were a lot of really high-rated papers. We had to choose. We picked the 2 highest ones. So let's start with the best paper. So let's start with best student paper. The award goes to Hannes Helmholtz, Ishwarya, Paul Kalamia, and Sebastian Gary on their work on towards the prediction of perceived room acoustical similarity. Hannes is going to present today at 11:30, so please don't miss the presentation. Would you be kind enough to give it to the rest of the authors? Okay. Thank you. Thanks. And the Best Paper Award, which was also first authored by a student, and I was told that it was his first paper, so even more impressive. Joshua Manal, Orki, Paul Kalamia again, and Enzo on the work on perceptual evaluation of low complexity diffraction model from a single edge.
Take a picture.
Yes, sure. And one last comment, you probably heard about it already. Me, Hannes Gamper, Prasanga, and Stefania, we took on ourselves to be guest editors for a special issue on the topics around AVAR. You should have received already emails with the call for papers. So please contribute. Please help us with reviewing those papers. We'll reach out soon again with that as well. And with that, thanks everyone.
All right, thank you, David. And next, I'm going to introduce our third and last keynote presenter of this conference. Karlheinz Brandenburg received master's degrees in electrical engineering and mathematics, as well as a doctorate in electrical engineering from University of Erlangen-Nuremberg. He is currently a senior professor emeritus at Ilmenau University of Technology in Germany, is also the CEO of Brandenburg Labs, which is a startup working on immersive audio technology. After his time at AT&T Bell Labs as postdoctoral member of technical staff, he moved back to Germany again to join the Fraunhofer Institute of Integrated Circuits as head of the audio and multimedia department. He was founding director of the Fraunhofer Institute for Digital Media Technology in Ilmenau, where he retired in 2019. For his pioneer work in digital audio coding, you may know as one of the main contributors to the MP3 and AAC audio coding standards, but also in perceptual measurement techniques, wave field synthesis, psychoacoustics, and analysis of audio and video signals. He has received many awards. To name a few, the Cross of the Order of Merit of the Federal Republic of Germany, IEEE Masaru Ibuka Consumer Electronic Awards, the German Future Award, and on Audio Engineering Society Silver Award. So with that, Karlheinz, it's an honor to have you today.
Okay. Thank you very much. So let's And yes. So, thank you very much for the very friendly introduction. When looking at the title of my speech again, I thought, oops, this sounds like I have all the answers. No, we don't. There's still so much to do in this area. And it's constantly changing. But before I go into the details, first let me do a few acknowledgements, because as usual, this is not just my own work. There's lots of people involved, and there are lots of people who helped me prepare these slides and so on. So some of them are here, like Franziska Wollwert, Ulrike Slomer, and Nils Merten of Brandenburg Labs, Florian Klein, Stefan Werner, Annika Neithardt of TU Ilmenau, but many more, both from IDMT and TU Ilmenau, including many students with their thesis work contributed. And of course, as we say, standing on the shoulders of giants, there's been many people before, and at the same time, without their work, this would not have been possible. Okay, to start with, I'll dig, as I like it, go to history a bit. Like the dream of high fidelity is nothing new. Give a very short overview of current understanding of listening, what our ears and brain does, but of course, within a few minutes, that's a topic for really courses for hours and days and so on. Since it's so much related, I'll go briefly into immersive audio via loudspeakers, which people have been doing very successfully for many years now. And then look back in time what has been tried to make the same impression possible via headphones. And that turned out to be much more difficult than the loudspeaker case. And that leads us to how, again, especially our brain works, what cues our brain uses, and what's the current knowledge and so on. For some of the dreams of applications, we need audio which is transparent, reaching our ears via headphones. And that's something which we can't do yet either. So I'll very briefly touch on that subject and then talk about some of the applications we have in mind. Okay, let's go back 100 years or so, or more than 100 years. For the historians, it's well known, but for me, I only got more details about this a couple of years ago. Thomas Alva Edison was obsessed with audio quality. He really wanted his systems to give you what today we would call transparent audio quality, really the best. So he sent people around the world to demo this. And there were places where they had early on the phonograph, later on better systems, the so-called diamond disc, and demoing the comparison of a real singer or cellist or whatever, just one person playing an instrument or singing, and his reproduction system. And the light was dimmed, and people were asked, okay, which is which? And the story goes that they couldn't distinguish, which from today's view is difficult to understand, especially if we think of the scratchy noise of a phonograph. In fact, what we can learn from that period is, yes, high fidelity has been a topic all the time long. Yes, already at that time, psychological influence has been big because people just didn't expect it. I had similar experiences early on with audio coding when we had strange artifacts, but people didn't think this was a codec. So they didn't even hear it. In fact, for these demos, we are told as well that the singer or the cellist practiced a long time until their sound sounded like the phonograph or diamond disc. Anyway, could we do that today? I would say with mono, yes. To compare to a jazz compo or a symphony orchestra sitting in an orchestra in a hall, no, that still wouldn't be possible to get exactly the same sound. Headphones sitting there, no commercial system which could do that in a way. So clearly we have to learn something more about how our brain works for these. If you look what's important for hearing, for our ears, there's all these well-known effects, like we have the absolute threshold of hearing, we have masking, we have binaural masking. All stimuli go to the central nervous system, which uses what we get on other modalities as well, and which bases our sensation on belief, what we think we hear. And that's very important. So first of all, a slide I got from Jim Johnston, just telling us, look, it's not just a linear combination of, yes, we have the outer ear, inner ear, nerve fibers, and so on, but even high up in the cognitive system, in the brain, we got feedback even to the outer ear. So what we hear and what we think we hear really influences what we actually hear, even to the physical sense. So just first reminder for everybody who is well trained in electrical engineering, we liked to do optimization in the linear domain, speaking about LTI systems, linear and time variant. Sorry, all that is nonlinear. So what people started early on, we have to optimize for better signal-to-noise ratio. No, that's basically in the linear space a measure. This doesn't help us at all if we think about audibility of artifacts and so on. So in a lot of cases, it's the other way around. If we have a certain system, we optimize for signal-to-noise ratio, we will get worse sound quality. Should be remembered. Now, of course, most people, especially whoever has been trained in psychoacoustics, knows that, but I still meet from time to time people who think, oh, but that's optimum. No, it's optimum to the opposite of what our brain notices. And yes, time variant. Our listening evolves over time. We get this neuroplasticity, as it is called. And in fact, there are different effects. In audio coding, we've been used as some glass ceiling, but up to that, we could train ourselves and get more and more become able to distinguish coded and not coded, and so on. In spatial audio, in some cases, it's just the other way around. We can learn to listen with other people's ears. We can learn to get the sensation of having spatial audio even without head tracking in some cases. So it's just the other way around, and Florian Klein, who is here, did his PhD on this because there's not been that much literature on these effects. But going back to the point of basing what we hear on belief, there has been a great experiment by some master student of the University of Huddersfield in England, and he did an experiment with lots of listeners. And you know, there are still a lot of people around who claim vinyl just sounds better than digital, which by itself doesn't make sense. It's just every medium has its shortcomings, and some people like the sound of vinyl better. But what he did, he played something, some vinyl disc with a needle on it. You could hear the scratches and then hear the sound. And then he switched to something. He said, okay, that's now directly from a digital server, and asked people what is better, with them seeing this. And from the people he interviewed, he got 60% to prefer vinyl, clearly statistical significant in this experiment. What people didn't know was that this disk just had a time code on it, which was used to synchronize the playback from the very same source which was declared as being digital. So people compared A to A, but since they saw the disk spinning, they liked it more. We have to keep that in mind, and nobody can evade these effects. Okay, let's go to immersive sound, where I don't know how many Trekkies are still here. It seems it's the older people nowadays. But in Star Trek, there's this nice idea of the holodeck, which lets you virtualize everything. It even hurts if somebody attacks you, but you can switch it off just with a command. And that's an old dream, how to do that for audio and video. And for audio, we got the loudspeaker-based technologies, starting with surround sound many decades ago, ambisonics, wavefield synthesis, vector-based amplitude panning, and so on. And for headphones, okay, that's the main topic of this talk. Let's just go a little bit to these things. Ambisonics, okay, that's a culture war in some sense. I belong to the people, I have some training as a mathematician as well, so I like the mathematics of ambisonics. Especially higher order ambisonics can recreate a sound field in a room. That's theory. In practice, from my point of view, there are enough shortcomings that I'm not really a fan of ambisonics. But today, especially since this is nice to teach at a university, there are many people trying that. The other way to do it is wavefield synthesis, and it goes back, in fact, to the same formulas. It's a wave equation in the end. And it's based on something which we've been taught in school, in optics, like, yes, if you have a primary source, you can get the same wavefronts if you have secondary sources with the right delay and amplitude. That's basically it. And that's been people in Holland and Technical University of Delft who worked on that to just apply the idea to acoustic waves. And yes, no, that's the only formula for today. In the morning for a keynote talk, there should be not too many formulas. And I don't want to go into detail. It's the reason why we can use everything on the outside of a sphere to get the exact sound pressure, density, and so on inside. And that way we get the right wavefronts inside. But, of course, with a lot of simplifications, which make you wonder why this should work. And the reality is just, with wavefield synthesis, we've seen lots of very convincing demos and applications that you really feel like you're somewhere else. You just need a ring of loudspeakers around yourself. So with that, you have this ring of loudspeakers. You have a large number of individually controlled loudspeakers, and they create a wavefronts and an area where everything's fine. That's okay, enough of that for today. let's go to headphones. And while loudspeakers, we know it can work with different ways. We have all these commercial systems as well. With headphones, usually people started to think, okay, we have 2 ears, so headphones should be fine for everything. No, usually the sound comes from within the head. We get front-back confusion. It does not feel real. And even traditional stereo is defined to be monocompatible from old times. So the phase relationships disappear. That makes it even worse. We just can do amplitude panning. In fact, there's one simple argument why this happens, and that already has to do with what we detect in terms of directions if we listen. Humans always turn their heads or walk around. In reality, if we do this, the sound coming to our eardrums always changes. We don't realize that. It all feels natural because our brain knows how the sound changes if we walk around, turn our heads. That's the famous head-related transfer functions, different directions, different frequencies, and so on. And from that, even in mono, already our brain can detect directions. But if the sound doesn't change if I turn around, then the only way it can come from is from within the head. Very simple. Okay, so what have people done over these 40 or 50 years? I think at the time Star Trek just started, people already had the idea of dummy head recording. To have a dummy head with microphones in there and use these signals directly to feed to your headphones. Which still doesn't change the sound if I, as a listener, move. In fact, I got some early demos where they connected the dummy head to people's movements, which would work even better. But at least the time and phase relationships are kept. There are some HRTFs used. And that means for some things, we get already convincing illusions. With dummy head recording, you can have somebody whisper into your ears, and it sounds like somebody whispers into your ears and not in your ears. But clearly lots to be desired. So that's the earliest idea some 50 years ago. Then people really early on found out, no, this should be much better if I use head tracking. Especially first it was just 3 degrees of freedom or just turning around the head and getting these directions. And I remember some early demos which were again very convincing. Who here has heard the convolvotron? Okay, oh, as well, very few. That was late 80s, NASA Ames research, which did that. And it really sounded like a game changer. We can do that. It needed a battery of digital signal processors to work. But you could get some convincing localization, but still not enough. For some things it worked, for others not. Next idea was, okay, we know HRTFs are individual. We all have different forms of our pinna, of our head, different dimensions, and so on. So why not individualize this, measure the HRTFs per person? And in fact, tons of work went into that. And I will be in this talk the bad guy saying, yes, the idea is correct, but we don't need it in a lot of cases. But there were the questions how to interpolate these HRTFs, what's the accuracy needed. There are publicly available databases for HRTFs, and so on and so on. So all this had tons of work, but still you could not get a convincing illusion in all cases. Sometimes yes, but not always. So next idea, which was done in different ways. In fact, first people said, okay, but if I'm in a real room, I always unconsciously listen to the reflections in a room. And my idea of the localization of some speaker is influenced by the reflections in the room quite a bit. So to model that, we need a model of the room in there. And again, there's been a lot of work in different ways. One of the newer ones is within the upcoming MPEG-I standards. There's a format called LSTF, Listening Space Descriptor Format, which tries to catch that. There's a lot of work currently going on in that direction. There's a question, when can we distinguish rooms and when are they so similar that we can't anymore? What accuracy is needed to get a plausible reproduction? So there's more and more work on this, even in our own group in Ilmenau. I'm not yet convinced. What I find is that all people to try to use parametric descriptions still have some shortcome. We don't know yet, is it just limited accuracy? Or is it something in the real room impulse responses which we are missing? In fact, there's, and we'll get more on this in the talks later on, there's some nearly consensus that yes, the first reflections are most important, and then for the later part of the impulse response, we can just take one prototype and use it for all their directions. There's people who are not fully convinced and think, oh, maybe there's something in there which we miss. So that's ongoing research, really. But yes, it's consensus we need some form of room description. And as I will show later on, from my point of view, we even need a measurement. And then people used all of the above together with training. And still not that easy and not good in all conditions, but for me, still the best commercial system available in the moment is the Smythe Realizer. And there you have a setup time where you have microphone in your ears below your headphones you're listening to later on. You have some knobs to turn things, and in this process you do actually some training yourself. And you get the amplitudes adjusted, so it's fine. And so this has a bit of HRTF individualization in there, and it's doing training at the same time. But again, if you use it often, it will be great, but in other cases, it might not be what we really want to in terms of full plausibility. So let me go to some of the newer research in that area. First is, in more detail, we need to use the actual acoustic properties of the listening room. We need to take care of training effects and what people have been overseeing for quite some time. And in our group, it's especially Annika who pointed us to that. Where is she? There, back in the back. 6 degrees of freedom. If we move around in the actual listening space and the sound to the headphones matches what the brain expects, that's again a very important cue. So let's first look at these divergence effects. And that in fact went back to an old observation. So very long ago, I remember I did some very crude experiments, even being a child, with a stereo recording system, 2 microphones in a room, recording myself walking in that room, then listening to it, and I thought, oh, did somebody come in or was it the recording? So it was very, very convincing. And talking to others over the decades, I found that as anecdotal evidence, this had been found by lots of researchers in the area. So yes, if you do things in the same room, suddenly things are much easier. So that's what we called, in fact, Stefan, who is, I think, sick, so he's not yet here or won't be here today. He called it the room divergence effect, like if the room is different from what we expect, again, the brain gets into trouble. And in fact, whenever the cues don't match up, our brain says, okay, then let's get in-head localization, front-back confusion, and all this stuff. Of course, there's other kinds of convergence or divergence, like the ventriculoquism effect, that what we see influences what we hear. But let's go first to a very old slide from Stefan and others, and I don't want to get into that much detail here, but we just had simulation of rooms which were known or not so well, or where people were in or not in, and in fact, which were dry or less dry. And the basic effect is, if the room is dry and you are in the same room to listen, then the effect is strongest. No, if it's wet, sorry, wrong. If you get reflections in the room and these are well in the system, then it works best. And free field conditions with a dummy head, you get nearly no externalization. In fact, let me introduce that. For the question how to measure these, I really, as of course we'll get later to that, there's a number of other things to watch as well, but I like the idea of externalization because for me it's really a switch. Either the sound is near my head or in the head, or it's out there. Of course, if you average over people, you will get to a scale where you can have intermediate values. But in the single case, we have different circles where we ask people where is the sound, and everything but the outward circle we call internal. So it's 0 or 1 really. And there we get these clearly statistically significant values for this room divergence effect, which was good because there had been some talking, but it was not in the textbooks until that time. Now we can find it showing up more and more. Often I'm asked, okay, but isn't visual influence the most important part? So during the work for his PhD thesis, Stefan did some experiments with students as well. And don't take these 16% literally, please. It's just telling us, okay, there is an effect, but it's by far not the most important effect, what we see. What we see does influence what we hear, but in this case, for externalization, there's the other effects which are more important in the end. Then, at the same time, we looked into personalization, the individualized HRTFs. And yes, this helps to increase the individual binaural synthesis for us. So it does help. In one experiment, we even found, oh, this might be more important than the room divergence. No, with the newer experiments, which what we can show now, there's considerable doubt, and it looks like that still there might be some effect of individualization which helps, and there might be people with so much different head geometries and HRTFs that a standard average or standard HRTF doesn't work. But I'll get to that later with the experiment we are showing here, the demo. We now have more than 300 people, and out of these 300 people, I think 3 didn't get the same externalization as the others, get some trouble with elevation cues. So for all the others, the standard Keymer HRTF worked. So that's for me a very strong argument that we could live with either very simple HRTF individualization or none at all. Okay, let's go to the time varying effect. In fact, there's been work now over years. The real experiments we would like to do, like letting people listen to the same type of sounds over years and see how their ability to get externalization and to get plausible reproduction evolves, that's not really feasible. So we don't have these results, but there's short-term training, something which you go into a room and within seconds your brain has an idea what the room sounds like. And remembering things over a very long time, or listening to certain types of audio over and over again and getting trained to that. That's there as an effect as well. So we got learning, for example, listening to the direct to reverberant ratio, which corresponds to distances. And in virtual rooms, over time in the beginning, externalization increases as well, so we can adapt to that. Understanding the scene is important. So even exploring a scene and getting some idea what is where, and that adds up to a picture. In fact, there's still some controversy I hear among people in hardcore psychoacoustics, whether these are just certain cues or whether our brain builds an internal picture of the surrounding. I'm tending more to the second, that we really get an internal picture of what's around. But I got very vehement contra from some people. Okay, and how do these different effects link to each other? How do they overlay? Would be great to know that. As an engineer, I always want formulas, but we don't have them here. Just some picture, again, from a publication of Florian Klein from a long time ago. And I think the most important is looking at these depending of two groups of students which had been trained, listened to the system in different rooms. One is our listening lab, which is quite dry. The other one is a seminar room, which has lots of reflections, like a lot of bad seminar rooms have these days still. And you can just see externalization index, the red parts, left and right, very different, so clearly if you do the math to it, it's significant. And if you look closer, you can find things like front-back confusion and so on, but that's not the point here. Okay, next thing, I already touched on that. Moving through a virtual scene, in fact, whether it's VR or AR. In fact, in AR, it's even more important. When we move, this enhances immersion quite a bit. And in fact, we didn't talk about the definitions. I like the definition of plausibility, the best in the moment. And plausibility for me means that if I don't have something to directly compare, I only have an internal reference. It's plausible when I don't know whether this could be real or not. That's plausible. And the other immersion is, yes, I really feel like I'm somewhere else. Spatial, I call all the rest because these terms really have been misused by a lot of systems which don't really earn any of these definitions from my point of view. So yes, the emergence of an auditory illusion is improved when I get through the scene, it's tracked in the right way, and that means my brain finds congruence from what it expects, what it sees, what it knows, to what it hears. And the same early on is just rotation. We know that reduces the front-back confusion and it supports externalization. And really, translation allows a better understanding of the scene. And as we will see later on, when we look at references, translation helps to really get an internal reference to what we want to listen to. And we can compare that to the external sound and then find it works. Okay, so in the end, what we need is a match of a number of cues to what our brain really expects. So that's the cues for our anatomy, HRTF including ear canal geometry, cues for the room, reflection patterns, in fact exact, so better measured than just models, because all the models still have problems. Visual cues. Proprioception is the feeling for your own body, which is important. And our experience. And in fact, the experience can overlay a lot of the other things. But what we want, if we do something for consumers, of course, is they should be adapt to it within a few, let's say at least, at most minutes, if not faster. If they have to train for weeks, this is nothing for consumers. All these cues are important. There is no linear combination which is best. What we can say is if something's completely wrong, then the illusion will break down. But what does completely wrong mean? What is the trade-off really? There's a lot still to be learned. And in fact, one of this is from our current experiments, we see that the cues for our own anatomy can be quite a bit off, and it still works. Don't need as accurate as people thought before. And we have the demo system here. I assume, who has heard it of the people here? I think most, yeah, looks like. So there we, according to these things, just try to do everything right. So we get visible loudspeakers, helps. We get an internal reference because we tell people to first walk around without headphones on to get a feeling for what these loudspeakers sound in this environment at this position. Then we do some measurements of room impulse response. And this method is a combination of what has been done at TU Ulm now and published well, done in Cologne with Christoph Perschmann and his group, and some more tweaks. I can't tell you even all the details because I don't know them, not because they are secret, because I don't know them. Of course, some of them are secret as well. As you experienced, we don't do any individualized HRTFs. That's standard KEMA HRTF from the SADI2 set. We have these algorithms to modify the room impulse response depending on the source and listener position. The source position is fixed, but the listener walks around. And we again do some published tweaks and how to modify the room impulse, the impulse response with direct to reverberant ratio, initial time delay gap, and so on, to get something which is near enough to what the brain expects. And then we switch between real loudspeakers playing, just virtualized, or even one virtualized, one real, and ask people, having a chance of 50%, what is what. Okay, some pointers to more details about all this and what's ongoing research work. I don't have the time here to do all of that. Annika Neithardt has a workshop starting at 11:30, so directly after the break, on modeling the perception of early reflections for efficient binaural rendering. And she tries out what happens if she puts in unnatural spatial temporal patterns of early reflections. So has the loudspeakers turned around and not noting that and things like that. So there's a paired comparison with modified versions, and I think the broad result is it worked better than expected. Correct, Annika? Yes, she nods. Then we have Florian Klein's talk about auditory room identification in a memory task. Again, how fast can people memorize rooms, what parts of it they memorize, and what importance there is. And then I just heard that Stefan Werner this morning reported sick, so we don't know whether he will be in, but the paper anyway is out there. That's again one of these tries to fit rooms to synthesized rooms, where I said I'm not fully convinced, but of course everybody's trying because that would make things so much easier. And then let's go to the question of evaluation of all these. And in fact, Annika especially has done a lot of work on that. And we got from the people on Berlin and others the idea to use the wordings of authenticity, plausibility. Authenticity is what we used to do in audio coding. We can do a direct comparison and we say, is it the same? If it's the same, it's authentic. If it's not, okay. Which is a bit more difficult if you are on a 6 degrees of freedom system and you can walk around. So what is really authentic there? And of course, is that really needed? No. For all the applications, what we really need is plausibility, so that we could mistake it for the original, even if we find there's some slight difference. And in both cases, this started with a real version. So we have an internal reference or an external reference, which helps us there. Of course, there are some applications with fictive contents, like sounds which never could happen in nature, animals talking to us, the fairy, a ghost, all that. So we need to extend these ideas to fictive content, but really, for the start, especially in AR, let's go for plausibility as the most important cue. And what can we find out there? This is just here a big caveat. As I said, I like to think about externalization as the most important and easiest to detect quality parameter. But all externalization doesn't help me if I turn around and suddenly the sound stage does a jump and I have clicks in there and so on. So I need stable localization and I need something which does not give me any of the standard problems of audio reproduction. So coloration is a big issue because it's very easy to get some comp filter effects or very easy to get the slightly off. You just need to be very careful. In the moment, I don't know what else to say because measurements always would be static again. but on the other hand, you need best experienced listeners to make clear that there's no coloration on the sound. And of course, then there's the effects which you can get if you know how the renderers work, and you always have some time from the actual tracking to the renderer and back to your headphones. If that's too long and you do very fast movement, then of course you will detect what's virtual and what's not. In the moment, that seems to be work quite well. And there's some rough estimates that it should be below 50 milliseconds, but that's from some experiments done in Berlin quite some time ago. And I'm not sure that will stand this number. We might even have to go to lower numbers. And then, of course, there's near-field effects. There's the well-known effects of some of the HRTFs that the height gets wrong, and so on. Okay, let me shortly come to this other problem. For some of the future applications that we would like to have sound come to our ears, and even with headphones, it sounds like the natural world out there. And I assume all of you have worked with some of the newer noise-canceling headphones where you can switch to a so-called transparent mode. And it's sorry. Yes, you hear what's outside. No, it's not realistic in any way. It's just you can hear what's outside. So in the end, we want really to have the feeling of the real world. Like if once I have glasses, I can see everything very natural. So this includes sounds from all directions. We have delay, of course, if we do digital signal processing, analog noise cancelling headphones just say below 1 millisecond of delay. You can easily calculate how many digital signal processing steps you can do within 1 millisecond. It's not much. So overall, that's still, for me, an unsolved problem, where we see research work going on at different places, but I have seen better and not so good systems, but not a full solutions. So let's go to what we want to do with all these in the end. And this idea, I think it was already presented 4 years ago here. Students of mine called it personalized auditory reality party. So one application would be if you are at a party, cocktail party, you have your headphones always on, you hear the environment like it is, it adapts to the environment in real time. When you walk around to the next room, it all does all what's necessary. And you can modify your soundscape in the way you like. So you need, of course, to detect the soundscape and to detect everything. But if somebody yells, you can tone down this person. Hopefully, he or she doesn't yell at you, because that would be bad. You can tone down the overall noise. You can have people at your table, which normally you don't pick up. You can say, yes, I want to listen to them, and so on and so on. And this is not just for being with other people, but you could do some listening to music in the traffic, and still all what you need to hear gets in, and so on. So you need very good externalization that we basically can do today. You need very fast adaptation to the room. You need auditory scene analysis in real time. Okay, I'm already told that's a bit science fiction. Okay, let's give it a few seconds to adapt, then it might be possible. You need sound source separation. Again, there are very few systems now just coming up with give you high enough audio quality. The traditional source separation I heard at conferences in the last decades always had very audible artifacts. And of course, you need a user interface to get the right user experience in the end. So turning your head, talking to somebody. In fact, what we do, this is another picture where we had more complicated soundscape at some conference a few months ago. And again, this is just to give you a glimpse of what should be possible in the future. Then we are working with other companies in the video field as well and computer graphics to get what we call multi-party augmented reality telepresence system. And it's work like the Jedi conferences in Star Wars. Like you have some people in reality, some people virtual, but they talk like all are in reality. And you can even turn your head and talk to somebody and the others don't get disturbed, and so on and so on. So if people working on 3D avatars with realistic facial expressions and gestures to ensure natural interaction, we get immersive audio via headphones, of course, that's what we try to do. And we get other companies and want to get that out a few years from now, let's say. Okay, let me conclude, so we still have some time for discussion. It has been said here before, audio is often, yes, we need this, we still have 1% of the budget available, let's do some audio. But in reality, it's much more important than that. It's a big part of an overall media experience. Even more than in other modalities, audio is subject to I hear what I expect. We should always keep that in mind. Whenever listening is involved, we need knowledge about cognition. And that's where we interface with neurosciences, where we learn from psychology. And yes, the simple sentence is ear and brain are not linear and time invariant. I do not believe in simple models. So sorry, whoever thought, okay, once we get the HRTFs right, everything is solved. No, it's more complicated, sorry. And even we need less of the HRTFs if all the other stuff can be done right, but there's still a lot of work to be done. Looking back at the old ideas of Thomas Alva Edison, we can say there's continuing progress regarding sound in rooms, leading to some very convincing immersive experiences, but there are some old questions which are still unanswered. So there's plenty research, plenty work, plenty of product development to be done, and that's really fun to be in that. Thank you. Okay, you want to start? Yeah.
Thank you for the very interesting talk. I think for practical reasons, there's a lot of interest in eyewear for these applications, and then open ear instead of headphones, right? So I was curious in this demo and this part that you talk about training, how important is to actually have the source in the environment. I would assume that if you are walking around with like a glass and your ear is open, you already have some adaptation to the reverberation of the room. But my interest is, what is the importance of the source being present, like in the demo with the loudspeaker?
In the demo, the source was important because we modeled the characteristics of the loudspeaker. So you could go to the near field and it still sounded convincing. If you don't know that, you are in trouble. In real world, maybe you have just some library of possible sources, and we need to find out which sources we need to know in which accuracy. Like what's the usual human person really have in directivity, and what happens, we see people turning around and so on. So I would say there's a lot of development work still necessary. Some of it is necessary, but it's not like in this demo where it's of utmost importance because we tell people to go near the loudspeaker.
Yes. Okay, thank you.
Thank you very much for the fantastic talk. I'm very curious, but could you please clarify what aspects of ambisonics you do not like?
Of course, that has historic reasons, because we did wave-field synthesis for a long time, and of course I learned about ambisonics, I learned about mathematical things. But what I see is, if you do lower order ambisonics, you have the sweet spot problem again. And of course, that's what we want to get rid of. You want to walk around in a room and still have a convincing experience. And I think a lot of the systems rely on exact loudspeaker positioning and so on. In wave-field synthesis, we do these measurements anyway, so we know the exact. But I think a lot of practical systems, it's more difficult. And what we've seen, for example, in the MPEG-I first tests was when people used ambisonics. Yes, the sound was somewhere, but we couldn't get the precise localization as we would get with the object-based standard reproduction.
Thank you very much.
Hi. At Sonical, we are building ear computers.
Yeah.
And so do you have any sense about how much compute and memory we're going to need to deliver this kind of experience?
We need to discuss that with you. I think the one who has the best current estimate is Niels Merten. Where is he? Oh, he's at our demo in the moment. He's over there. Let's say the current demo runs on an off-the-shelf PC laptop, which has a graphic interface which is just needed because we connect an HTC Vive for our tracker. So it doesn't do any computation, but it needs to be there for the software. So it runs on a current standard CPU with clearly less than 100%. If we get in some of the more advanced features, of course, we will need more computing power as well. In the moment, we could do an estimate from the classical, okay, how long is the filter we want to convolve with? And that's basically, we need the storage for the different, the interpolation, which is quite fast, and then do the convolving with what we got from the head tracker, which direction, and so on. Okay. So we talked to one company which have a 2-core ARM of not the newest generation in their headphone, and we estimated that's not enough. So
Okay, so whatever they have, you need more.
yes.
All right.
And we need to talk to you, but it's not the world, but in fact, my approach for all these years has to be first to try to do it that it sounds perfect, and then to find out where you can cut edges. And that's more efficient implementation and doing things with less accuracy and all that stuff. But don't do it the other way around. That will not be, people will not be happy.
Yeah. All right, thanks.
Yeah. And we are looking forward to talk to you on this. I think
So it was interesting to hear you talk about the ears being time variant. And
Yeah.
I was just thinking, just in the cases where we use generic HRTFs, is there justification for encouraging everyone to conform to a specific set of generic HRTFs? So for example, KU100 or KMAR from the SADI2, so that the general users can learn this generic HRTF set and get a better experience by learning it?
I don't think that will happen. Yes, of course, there might be some learning there as well. But what we find in the moment that this, in our demo, is instantaneous, basically, or a few seconds of getting accustomed to it. So you get this, you walk around, and that's the more important part. If you're just standing still, it won't work. And with that, it seems the standard HRTFs are accurate enough for this demo. So no training on these, because this works with people who have never used these before, and it still works.
Okay.
Yeah.
Hi, thanks for your talk. That was lovely. I'm curious to hear a little bit more about how you envision the generic HRTF approach, which works beautifully in your demo. As you move from one room to the next, it has a different layout, or as you even move outside into a space where you can't use the setup
Yes,
as
yes.
easily. Do you think that individualization might help in that case a little more?
We might see some help, in fact, especially for the free field conditions. So our current system, we haven't tried it. We talked about for months that we should try it, but we don't expect it to work in free field conditions.
Yes, I would agree.
So
Do you think that, you mentioned that there's still a lot of research to be done, and I assume that includes, moving from room to room, moving
Yes.
into free field.
Yeah.
Do you think that type of research would take longer than the part that goes, the research that goes into HRTF individualization and trying to get at the problem that way?
Again, current individualization doesn't fully solve the problem. I haven't got, even with people using their own HRTFs, I haven't seen a demo which works as well as what we can show there. So it needs to be a combination, and it might be as simple as people switching through some examples of HRTFs and taking the one closest. Whether you really need these measurements or not, I am in doubt. Of course, the final verdict is still open.
Okay, thank you.
Hi.
Yeah.
So on the topic of generic HRTFs,
Yeah.
really what's going on, right, is you're imposing a different set of filtering
Yeah.
than you would expect on your ears.
Sure,
So I'm
yeah.
wondering, do you think that the sort of accuracy of the HRTF is separable from things like coloration? Because you might have an accurate HRTF representation with a generic, and you might be able to learn that, but does the coloration, the quality of the sound suffer?
From what we've heard and what we got as feedback from professional mixers, for example, no, it doesn't hurt. We had people from a recording studio, which is well known in Germany, using their own content, 5-channel mix, in our lab and listening to it. And while they didn't agree it's perfect, for them it was good enough to really judge the quality of their mix. And that would not be possible if there would be clear colorations if I turn the head and so on.
Okay, so small follow-up. So do you think that the coloration is also something that can be learned, or is it more just the localization aspects?
It's more localization. Of course, we always adapt to colorization. If we walk through a room ourselves, the sound changes all the time, and our brain adapts to that instantaneously. But to adapt for a better or worse coloration, that's an interesting question, but I think, from what I may remember, bad sound can be recognized by people who are trained enough. So if you get colorations on your overall sound, people, at least well-trained people, will be able to detect that.
Thank you.
Yeah, and it's people like Agnieszka who can tell more about that, I assume.
Thank you for the talk. I was just wondering about, it's like we're all talking about the issue with generic HRTFs. I was just wondering if you've measured the cognitive load on the process of it, and if you've ever thought about the impact on people with disabilities.
Not yet. And cognitive load, of course, you need different ways to measure it. So you can't get it from very
There's
simple
studies
experiments.
there's studies that look at pupillary dilation in the
Yeah,
process
sure.
of
No, no.
trial.
There's
So there is
there
studies
is
on that.
measurement methods, but we don't have them in Ilmenau, and we didn't use them yet.
Okay.
So,
Thank you.
but as in some other cases, people talk about cognitive load, and it seems to be a non-existent problem. Like I heard a lot of people saying, okay, but listening to MP3 is more difficult than to listen to the real music, and this, I think, has never been substantiated.
Hi, my question is not about HRTFs.
Okay.
It's about the room divergence issue, which I completely understand. And I guess what I'm wondering is, so for augmented reality, clearly having sounds in our existing space is important. But does that mean that virtual reality is dead in the water?
Okay, good question. For quite some time, we thought it's easier to reach plausibility in VR. We don't know why, but in the MPEG eye tests, we had both VR scenes and AR scenes. And I didn't really see a big difference there. So in VR, a lot sounded not like what it should sound like. But of course, that could be just bad implementations, because that comes down to very complex ways to model the whole scenes and so on. So I would say conventional wisdom is that because you get immersed by the video, it's easier for the audio to follow that. There's some recent, I would say just anecdotal evidence, not more, that this might not be true. So I don't really know. Thank you.
So if we could get all our panelists come up here. Sal is here. Sal, if you want to say anything to get things rolling, or no?
How late do you want us to run?
I think we need to give you a few extra minutes, so maybe till like 11:10. Would that be okay?
That would be great.
Yeah,
Yeah, I mean,
I'll try
we
to
can
do a little bit of a
because
buffer.
that still gives us 10 or 15 or 20 minutes.
I'll try
break
to wrap
before.
around 11, and then we'll do
Some
questions.
Perfect.
And so I'll introduce you.
Okay.
And then if you could introduce the other panelists.
Oh, yeah, I'll get them to introduce themselves.
Or yeah, however you want to do it. Do you have anybody remote?
Yes, Pete's remote. Okay. He's done a rehearsal on Sunday, but I don't know how any of this works.
How many panelists are we having?
So we have myself and then 3 people live. We have 1 remote panelist as well. Yeah. Okay. Mine is on. Mine is on. Hello, everyone. Thank you so much for your patience just while we get set up here. And we have Pete on the line as well. Thanks for your patience as well, Pete. Things ran a little long here. Sorry? Yeah. I don't know how to control that. Oh, can we make Pete really big? Okay.
One more from distance.
big microphone.
You can go, yeah. Pete, you need to say things, apparently. Okay, wow, that's magical. Pete, Agnieszka's just going to introduce the panel in a second. Okay.
All right. Hello, everybody, and welcome to our post-keynote panel discussion. I am very happy to introduce Sally Calloway. So Sally is an industry leading product and design manager of mixed reality, IoT, AI, machine learning, and interactive media. She has deep passions for emerging technologies and diversity. She's currently a senior product manager at Microsoft, driving AI futures with the Dynamics 365 Insights apps group. She's also the founder of the Women, NB, and VR group in Australia and co-organizer of the San Diego VR community group. Her contributions and standing within the industry are recognized by her positions on the AES Technical Committee for Game Audio, Spatial Audio, and on the Diversity and Inclusion Working Group. So please welcome to our panel discussion titled Audio in our Hybrid Future.
Thank you so much. Okay, thank you everyone so much for hanging around. This is the last day of the VR conference here. And I really wanted just to take a moment to reflect on how, public demand is often the incentive that industry respects as a viable business necessity for various technologies becoming products or experiences that many, many people use. And necessity is the mother of invention, and certainly there's been events that have happened recently which meant that a lot of people needed to start speaking to each other a whole lot more often and needed an improvement in the audio experience of doing that. So now we're going to explore a use case that became highly relevant due to that pandemic in the last couple of years that we've all experienced both together and far away from each other. So I brought together this set of panelists across both research industry horizontals, covering many different telecommunications use cases, from virtual, augmented, mixed reality through to even just regular audio phone calls that we needed to start with in order to just be able to talk to each other. So I'll actually ask my wonderful panelists, we'll go down the line. We might actually start with Pete to introduce themselves in just a couple of sentences. Pete, good morning.
Good morning. Yeah, it's 3 a.m. here, so excuse me if I'm a little tired. So yeah, I'm Pete. Pete Sterling. I work on spatial audio at Meta. I've been doing that for about 8 years, working on the core technologies, and then more recently working on the Workrooms product, which is a virtual meeting space, which was motivated by the pandemic, like Sally said. So yeah, really interested in this space of spatial audio for productivity and meetings.
Hong, when you're ready.
Great. Have to hold this. Hi, my name is Hong Sodama. I'm a senior product manager at Microsoft, responsible for Teams' audio quality and audio experience. I have many years of working on audio, from de-reverberation for my PhD thesis to other speech enhancement, and later on end-to-end audio quality. It's really great to be here.
My name is Paul Bousted. I'm the VP of Product and Architecture for Dolby.io, Dolby's developer platform. I've got 20 years of experience in voice communications, starting as an academic, and then I did a startup with some of my PhD students doing spatial voice in games, concentrating on trying to replicate really complex scenes. So if you had 100 people around you, how does that sound? And then spatial voice got bought by Dolby, and in Dolby we've been applying spatial audio and spatial communications to conferencing, to games as well. But now we're really focusing on VR, AR sort of environments and helping people have more social experiences for work and entertainment. And it's great to be on this panel. Thank you.
Karlheinz, do you want to say anything extra?
I already just talked, Karlheinz Brandenburg, known for my early work on audio coding, but later on wavefield synthesis and leading in Fraunhofer Institute, and these days at the university with a lot of PhD candidates and CEO of startup company in exactly this field here.
Great, thank you so much. As I've already alluded to, there was a major world event that happened quite recently. We already had video calls, we already had VR, we already had spatial audio. So what exactly changed, and how did that drive changes in requirements for the audio experience that we experienced in telecommunications? Hong, do you want to start us off?
Sure. I'm sure everybody here in the world experienced the change in their own ways. However, the video conferencing industry is one of the industries that experienced a significant change over this pandemic. And from a convenience or a novelty, overnight, it turned into a necessity for every single person almost from, in the world. And think about how many video calls you make prior to the pandemic, and think about how many you're making and all your family, and that's the change. So Microsoft, the Teams was, over that time, overnight, we started to scale up our service to millions of people, and now we have monthly 270 million active users in the world, and people are calling from all kind of platforms, desktop application, mobile application, web browsers, phones, and we need to support all that. And more than that, it's the expectation when, Karlheinz just mentioned it, when the first time you hear video conference or it's still a novelty, you're very tolerant. You think, well, this is great. However, when you're used to it, your requirement, your expectation is totally different, just like telephone. And back when people are happy with 300 hertz to 3,400 hertz of bandwidth, now we're asking for full band. Same with Teams, an application like Teams. And all of a sudden, people are expecting telephony, availability, reliability, quality, and from anywhere, from any devices. So that's a major, very interesting development we have to immediately, face and take care of that situation so that we can provide the necessary service to our users. So the other aspect of it is the requirement for people's needs to get together, to meet, so virtually, and that really accelerated the needs and for virtual meetings, like Microsoft announced Mesh last year in March. And that became accelerated over the pandemic because people do have the needs to come together. So I think we're really looking at to provide a whole the ecosystem of communication for Microsoft, for Teams especially, from the phone to desktop application to web browser to conference rooms and to the virtual world, how we connect everything cohesively and have a great experience. So that is something I think majorly changed through the pandemic experience.
Paul, sure.
So at Dolby, before the pandemic, we were actually working with a lot of our customers. We don't run, conferencing services, but we had customers running conferencing services, and we were working with them to really help improve the quality of structured meetings. And these structured meetings where, basically one person talks at a time, and you follow an agenda and you get through, and you want that to be a high quality meeting. At that time, really, if it was an important meeting, you would go there and attend in person and sit in the conference room. And it was really, if you were a remote attendee, you were kind of a second-class citizen. And it was actually really hard to understand what was going on in the room. So we spent time building spatial capture conference phones to make remote attendees more part of the meeting and part of the conversation. But then the pandemic hit, and everyone was working from home, everyone was remote. And the DSP algorithms, which really were set up for very structured conversations, people in controlled environments started to break down. You had a lot of noise breaking through, so AI noise suppression algorithms became very important. And people were not wearing headphones, people using laptop mic and speakers, and you ended up with a lot of issues from echo suppression. It wasn't the conversations weren't very duplex. And in addition, everyone was missing the more social conversations at work, around in the lunchroom, and also brainstorming sessions where you could break up into groups. And we had a lot of companies come to us and start working with us on spatial audio for sort of more social workplace type applications. So we spent a lot of time with startups. Dolby.io, we're a developer platform, so we're providing some of our technology to these startups, and it's really interesting working with them during the pandemic. The thing we found after the pandemic is that that's continued. A lot of people are still working from home and really want to be equal at home as if you were in the office. And a lot of IT departments want to have systems so that people at home aren't disadvantaged. So people are sitting around tables with their laptops with their video camera on, so everyone's got the same sort of video presence. So things have definitely changed with the pandemic around how traditional conferencing works and the need for sort of social communication environments in virtual worlds.
Pete, I know that you're online. I think you mentioned just previously that workrooms had to scale up immensely during the pandemic period. Can you share a little bit more about that and how that became a new use case and how that reflects on some of what Paul just shared?
Yeah, totally. No, what Paul says, like, totally aligned with my experience of the pandemic as well. Even just personally, I was being remote, always just like a face on the wall with a bunch of people in the room. And you definitely feel it's difficult to jump in with a latency, kind of ironically in a similar situation today. But yeah, I think like really breaking down those barriers with like social co-presence and creating that sense of being there with other people when you're remote with spatial audio and virtual reality is a really valuable one. And that's something that was a sort of effort that was happening at Facebook to try and use VR for various productivity use cases. And we've been exploring this. But when the pandemic hit, we really scaled up this effort. We just saw that like, hey, the time is now for this technology. And so it was kind of all hands on deck. So even our little audio team that was mostly focused on just sort of spatial tech for games and stuff like that, we got pulled in. We were working on the core product and just trying to like make the spatial audio experience as good as possible. And what was really interesting about that sort of environment where it's a meeting room is it's a very constrained problem. With spatial audio, you're often trying to solve the sort of general case and complex spaces with like doorways, hallways, indoor, outdoor environments, and getting the acoustics right is a really, really critical piece of spatial audio. And with workrooms, we had this really constrained problem. And also in the sense of dynamics, that you weren't going to have explosions and gunshots and all these really loud sounds. You didn't have to have sort of butterflies and mosquitoes and really quiet sounds. Like the dynamic range was the range of human voice, which is what we're attuned to listening to, and the acoustics of the environment was very constrained being a meeting room. So it gave us the ability to very accurately, at least perceptually accurately, simulate that and provide a really convincing experience. And out of that, we sort of found there were these sort of organic things that come out of it, like having side conversations and stuff like that. And yeah, it was a really interesting experience to like work on a spatial audio in such a constrained sort of environment.
Yes, thank you so much. Karlheinz, I think some of what Pete just touched on really speaks to some of the like content that you covered in your keynote, just around like what we expect in terms of our experience in different spaces.
I think during the pandemic, of course, all of us got used to look at some display with a lot of faces on it. And if people behaved, we got understood everything right, with the exception of the, oh, my microphone was still out. But all that gave us some glimpse of what we would really like to have in the future. And I remember AVAR 2 years ago, where we met in Altspace VR, which was a very interesting experience. And on the other hand, for me, it said, okay, this is where we are going, but we have way to do more. And I think that's independent of whether we can, which I prefer always, meet in person, we should continue to work on these social interactions, which are very natural and which gives us better working with each other in the future. And we have some use cases, for example, with senior citizens and their not just their kids, but more generations and how they could get together. This is, of course, will raise questions of the user interface for these and whether they really want to accept these technologies. And I think there's a lot of spaces where the pandemic has taught us what to do next, really, and to really go on with this.
There's definitely been some interesting use cases that you're alluding to now that we've all touched on so far. So I think, Paul, you mentioned blending the line between work and social, and I think, Pete, you can also have some input on this one too, where it's people very much associate VR with entertainment. So when we have these new experiences where we're all remote, but we do actually still want to be able to have those side conversations, have brainstorms, have colloquial conversations, and enjoy the environment that we do get by being able to call each other from other parts of the world. If I hear a Melbourne tram ding, I know exactly what that means, and that makes me feel like I'm at home. So perhaps sharing a little bit more about what some of those challenges that came out of these really novel use cases were would be great.
I think one of the big challenges is people, some people really want to wear a VR headset. And it's a great experience when you're in there if you've got, avatars that are quite fluid, and it's an immersive experience. But a lot of people don't want to wear a VR headset. So you actually have to have a hybrid environment where people can just join from a screen, get a good audio experience. The audio experience is key. Get a great audio experience and experience the video on a flat screen TV. But you still need to get gestures. You need to have your avatar in that virtual environment look like it's interacting with people. But you've got to enable people who just want to look at a TV screen.
That is extremely true in the case of Teams. For example, MASH used to be a separate application and go to the virtual world and you talk to people. And now we are incorporating that with Teams. So the virtual world is now able to talk to the physical world, your people on the phone or in the conference room. So that's extremely important. The other thing that Paul just touched is about devices. That's also extremely important. As a gamer, as a professional, we don't mind wearing a high-quality headset or, goggles. That's all fine. But for our everyday users, we found, for business purposes, their purpose is not to focus on audio or the visual. Their purpose is to get their work done. For those people, many people prefer open speakers, and it's just freedom. They don't want to wear a headset all day long. And many people prefer the untethered experience, so they wear a Bluetooth headset. And one thing many people may not know is the current Bluetooth standard doesn't even support stereo in a call. And you can't even spatialize. And of course, there's a call for action for this group is if you are a manufacturer and go implement the new LE audio and support wider bandwidth, support stereo, that's really, really important.
Yeah, we've experienced the same thing. People won't wear headphones. A vast majority won't wear headphones, which really impacts the audio chain as well. You've got to have spatial, which works on speakers. And you also have to have a really good echo suppressor, because if you've got multiple parallel conversations happening in a virtual world, you're going to get a lot more over talk of people and a lot more background sound in the environment that you're working.
Yeah, 100%. And just on the adoption of VR that Paul mentioned, I think that's a big piece as well. And we ran into that not everyone wants VR, or maybe not everyone has their headset charged at the right time, or they're kind of new, they needed to get an update. And that could eat into your meeting time. If you didn't spend 5-10 minutes just preparing everything beforehand, suddenly the half hour you booked out, you've lost 10 minutes of it. And so they're kind of all the teething issues of new technology when we're dog fooding this internally. So we always had the option to dial in from your computer normally. And so you can interconnect. And so we'd have a screen in the virtual world like this to kind of accommodate that. And then the virtual meeting room would be a box in your call where you'd see all the participants and their avatars. So it allowed that interconnectivity and allowed sort of organic adoption, because we couldn't force people to do it all at once, but there's always the option. And so we rolled that out to all of our meetings now. So anyone can join a meeting in VR, or they can use the traditional sort of squares on a screen method. And it finds a sweet spot between sort of like, getting everyone into the virtual space and just allowing people to do the basic functionality of having group calls and getting their meetings done remotely.
Pete, maybe you can comment a little bit further on like this flat versus virtual or flat in virtual. Like, how does that complicate the audio experience and like the perceptual experience that listeners were having in your space?
Yeah, definitely. So I think one of the things we learned when we were working on the virtual is we were kind of like undoing a lot of the features that existed for the flat space, because in flat sort of VC or even just phone calls without any video, we're really optimizing for intelligibility and making sure you can hear people loud and clear and everyone's at a similar level. And in the virtual space, that's not always what you want. I mean, one thing with spatial audio, you've got a much wider soundstage, so you can separate listeners much better, which is amazing. But also in the 3D environment, someone might be further away, and having them a little bit quieter can be better for the experience. And so having this actual unintelligibility becomes a feature where it was considered a bug in the flat space. And that's combined with sort of like voice directivity. You can have two people in the corner sort of facing each other, chatting. You're aware of them. If you really listen, you could probably make out what they're saying or get a bit closer and participate in that conversation. But also that conversation can exist in the space without interfering with your conversation if you're talking to someone else over here, or the main presenter's talking and a couple of people just wanted to clarify something or, make a joke or something. You can have these sort of more organic, realistic experiences, but it's a very different sort of problem you're trying to solve now. And intelligibility isn't always the first and most important thing for everyone in the room at the same time. So that was like one of the interesting challenges that came up of like how to make the virtual meetings more realistic.
Yeah, I think it's really interesting, the difference between the virtual and a normal meeting from a telecommunications perspective. For telecommunications, a normal meeting, quite often people have three loudest. You transmit the three loudest speakers, and that's fine. It actually reduces the background noise that you're hearing and things like that, and it's fine. But then once you do that in a virtual environment, if you just transmit the three loudest, then you're not hearing the people around you. People will cut in and out because you can actually separate voices. So someone over to your, if the three loudest speakers to your left, someone over to the right will cut in and out. And if you do the three closest, you walk into an environment and it's just like there's no energy in the room. You can't tell that you're in a room with a lot of people talking. So it's a very different problem.
Yeah, and that's basically the main point, that we need to get to a more natural feeling for the environment and use the cocktail party effect, which we are capable of as humans. And that's exactly what you said. We need to recreate all the sounds in a way that we still can support the hearing. If we just do everything, it might get more difficult as well. So we can support the one person whispering to the other one, and the other ones don't get too much disturbed, or I can concentrate on them. And again, in the end, there should be a user interface for that. I haven't seen that.
It's interesting to think, like, even as Pete, you were describing like the behaviors that people expect to have or be able to do in VR. It's the same. I expect to be able to do this when I go into a normal meeting room. If I want to have a side conversation, I'll just like scoot back. It's the physical experience that allows me to be able to like control that experience. You just mentioned like there should be a user interface for it. Hong, like how many more buttons can we stick in Teams? How do we give users control of that experience, like so that they can be able to like like moderate that and be able to switch through these different modes?
Yeah, it's a really interesting topic. We're actually exploring a lot of different. For example, in Teams, there's such a concept of a green room, and you can have like reality. You talk within before you become go out the stage to speak. And also we have live interpretation support so that you have a room with language support, so that you can hear some of the main floor, but you can hear this interpreter, but others cannot hear your interpreter. So all these are extremely important. One more aspect I want to invite everybody to think about is, although the ambience is really important, like P and Paul and Karlheinz were mentioning, is it gives us a realism. However, at the end of the day, we still want to hear, we want to listen to, and we still have a purpose of communicating, being able to perceive things clearly. And what I see as a slight challenge to us when we think about spatial audio is when we study music and we hear the reverberance, and that helps us externalize the sound. However, reverberance actually is detrimental to intelligibility of speech, and especially if you are a non-native speaker, like myself, and you will notice that your intelligibility, your capability to perceive some sound just drop off a cliff when there's reverberance and noise or some accent. But the native speakers, they're just fine. They're, gracefully, degrading their experience. But so all these are extremely important. So we face two challenges. One is to mimic reality so that we feel real. And all what P and everybody else was mentioning is extremely cool and makes you feel very comfortable. And the other challenge is how within this we can do better than real, right? We're not here just to mimic reality. Somebody in their presentation said it's kind of boring, reality is boring, right? We want to do better than reality. For example, simple examples like a teleconference, we can always mute. Let's say I just want to sneeze right now. I'm really embarrassed, but I don't have a way to hide myself. But if I'm on a conference, I can mute my camera, mute my microphone, and that is, so we're creating the reality, but we're creating something much better. Like another feature people behave very differently in teleconferencing is the recording feature. So that gets you so much, but if you come to a conference like this, you meet with somebody, you don't see anybody start a recording, saying, oh, I'm gonna record our conversation. How does that make you feel? But even in a teleconference, I'm recording probably 95% of all my meetings so that I could, take notes. I don't have to take the time to take notes. So people's behavior are very different. So I really invite us to think beyond reality. What is above reality we can create that we don't have today and makes the people's work easier, their life more enjoyable. So that's something I think is really exciting.
That's part of our vision of the personalized auditory reality, where you really can influence it to have enough feeling for the rooms. You feel like you're there, but you still can change what you hear to make these things possible. There's lots of work to be done for that, but that's really part of the vision.
Yeah, I think it's really... Oh, sorry, you go.
Just to Hong's point, yeah, like I remember seeing a thing about like classrooms. They're a really horrible acoustic environment with a lot of hard surfaces. And they tried doing like proper acoustic treatment on a classroom and found the students learned a lot better. So I think there's a lot to be said about like the potential negative effects of reverb. But I think we can do it tastefully and find a middle ground there and not necessarily have everything completely anechoic. So there may be some middle ground. But I do think that there's definitely a lot more we can do beyond reality. But I think it's always good to try and get as close to reality as you can as a baseline so you can know what that delta is as how much you've improved it.
Yeah, we did a lot of work around realistic rendering of social scenes with, say, dozens or 50 people around you. And we started off with rendering voices in the game engine based upon the location in the world, and then applying room effects based upon their location in the world. And then the listener would listen to that room. And it would probably sound realistic, but it wasn't. You'd get complaints that this is really hard to communicate. And so you get blamed for creating a bad experience. And what we started doing was mixing the voices separately and applying a more subtle room acoustic to it at the end, just to give a sense that you're in a room, a different type of room. And so making it realistic doesn't actually mean that it's going to be a great experience. So we like to think of something that's believable, but also usable and sounds great.
That P word, the plausible word.
Plausible, yes, I really like that.
Yeah, certainly. Like, how does that hash against, like, Karlheinz, the content in your keynote just around needing to find that room, like, image plausible as part of the experience?
No, that's of course something which will adapt in the your senses need to pick up the real room and know about it. And then of course you can change it to get still the feeling of the room, but being able to communicate much better, have cleaner communications, and there's all kinds of processing you could do then on the signals, definitely.
I suppose when I'm in a room, I don't really expect to see a wall of faces, tiles around me. So that is in itself a fictitious space.
Of course,
Yes.
yeah. No, that would be there already, as we talked about AllSpace VR or Mesh or whatever the systems are. There's already quite some development. But in fact, in some situations, when I have the team and 9 people around, the tile of faces is good. It's better than people looking around to find people where they are.
Yeah, Paul, this is kind of interesting as well, because Dolby.io is a developer platform. So how do you listen to like your developers and their requirements, their needs for moving forwards, the features that they'd like to see to help inform your development, what you're looking to support in the future?
Yeah, we have kind of 2 classes of developers. Well, we have 2, in the communication space, 2 main types of developers. Ones that are creating normal tile-based type communication environments. And there we just provide them with the ability to spatially locate voices based upon tile locations. We have people building spatial communications into large whiteboard applications so that you can have a conversation around the bit of work that you're doing, and you can hear conversations in the background of people working on other parts of this big space. But in virtual worlds, we get a lot of demanding requirements. We've got customers that are building just simple virtual worlds, which are online meeting sorts of environments. But we've got people that are creating, say, online concerts, and they want to actually have an audience which can all cheer at the same time. So you have 100 people making noise at the same time. And so taking in all these requirements is really interesting. And so we've had to provide quite sort of intricate and complex controls on how you control spatial location. And in the end, what we found is that we can't really tell what people are going to do. We just give a lot of flexibility in our controls.
We have about 10 minutes before we're going to wrap for questions. I'd love just to continue the conversation about what we think might be next, what roadmap and like future vision we really want to challenge like the folks in the room to think about when it comes to audio experience in telecommunications, or at least and hybrid spaces as well. Anyone can start.
Thinking of a roadmap, of course, it's really the question, what can we do with current systems? Mm-hmm. For some of the ideas, we will need different headsets, different hardware. Some can be done with the current ones. We will have to go for the combination of different hardware, even no headphone at all, which I don't like, but yes. In fact, personally, I use just a conference microphone at home. And with that, the roadmap is really to look around what's commercially viable on one hand, and where we get the right hardware. And that depends on all the manufacturers. I don't think Microsoft is a hardware manufacturer, but the others are not.
Some Surface, yeah.
Yeah. So otherwise, it's really a question to these guys as well, what we will be able in the future. And I think there's a lot of great people around to do the best possible ways. One thing which isn't in the current roadmap that much, but I think for these applications, some more interoperability would be very nice. And that would mean some standardization or whatever, or at least people coming together from the industry to define APIs and so on. So I don't like to be locked into one company's ideas.
Very fair. I think also like Microsoft has like whole conference room experiences you can buy too. So
Yes.
there's like the Surface devices and a whole bunch of other stuff too. There's
Sure.
headphones as well. Yeah.
Yes,
headphones
we
as
have
well.
Surface devices, headphones and laptops, and we have also an ecosystem with partnerships. So we have a certification program. If you have a device, you get certified, and you can work with us. So we have a lot of partnership. So in terms of the future, a few aspects from the team's perspective, and remote work is here to stay, and people are also starting to go back to work. So here again, we can no longer avoid the issue of hybrid work and hybrid meetings, right? So we have this people in the physical world together, and we have the people in the virtual world, and they're talking to each other, people on the phone or on their laptops. How are we going to create a cohesive environment and to make people feel they're sharing the same audio experience? And so that is a very interesting challenge. And also, even within the conference room, people want to bring their own devices for different reasons because the displays are not always as good as my laptop, something I want to share. How are we going to incorporate all these from audio aspect? It's a really, really important thing. And looking further into the future, when I think people will take it for granted that no matter where you are in the world, I want to feel like you're in the same room with me. And how do we create that, communicate my sound experience to you? And I want you to feel like you're in the same space with me. And literally, or how I can choose the sound I want to hear. You're in a public place, and you have different noises, but you have birds chirping and waterfall. I want to choose the sound I hear, and how are we going to handle that? And another impact is the visual part of it. And it's extremely important, like Karlheinz in his talk about how that can guide you to believe the sound is coming from here. And we found this to be a very less studied, seems like, area, because audio people study audio problems, video people studying video problems. What's the interaction? What does it do to each other? And I think all these are extremely interesting and exciting area that I ask everybody to think and explore.
Paul, anything to add?
Yeah. So yeah, Dolby, we're really interested in events, and a lot of our vision going forward is around how to create really compelling online events. It's great to be back at a real world event because online events aren't that great at the moment, and there's a couple of big things that are missing. One is actually the presenter interacting with the audience as they speak. You do an online presentation, you're just doing it dry. So that's something we really need to fix on online. And there's also the social interaction between audience members and the presenters. And so these two things have to be fixed for online conferences to be, good. But I think we can build to a world where online events can actually be better than the real world because you can control the environment. You can have a great looking virtual world with awesome acoustics and really understandable voices. And you can join conferences no matter where you are in the world. You can actually get much more attendance at conferences. So we're really looking at the future of these online events and how to make them better than real ones. And one step further, we're looking at how you could do something like a virtual concert online where you have a band playing on the stage and actually reacting to the energy of the crowd, and the crowd being able to roar and the crowd members feeling like they're in a crowd. So that's kind of that's a long-term goal to try and build really compelling experiences there.
Pete, what have you got from the workroom's perspective?
Yeah, totally. I think like what we learned from workrooms was a lot of we can do a lot with what we've got right now, but there's so much more we could potentially do if the whole pipeline from the hardware to the firmware was all tuned for making the spatial experience as good as it could be. So there's definitely a lot of work going into thinking more about that for our future line of devices. And we've also just realized how important spatial audio is, and I think that's impacting the roadmaps of other teams and other products as well, to see how we can bring spatial across more of our services to really enhance the experience.
Yeah, I think I've heard it more than once throughout this conference. Like, I think the call to arms is really like, what is the perfect experience that could exist? And it's not just about like focusing in on like, well, telecommunications is kind of boring. It's phone calls and screen tiles, but what should that experience be like? And what does that experience accrue to in the long term as well? I think what we can do now is we can wrap up and give some time and space for people to ask questions as well. And also because there is a coffee break before the next session as well. So I'm gonna make sure everyone stays like a little bit caffeinated so you can stay energetic throughout this like really long 3-day in-person event. But I definitely want to make sure to thank the wonderful panelists that have been here today. So Karlheinz, thank you for joining us after giving the keynote presentation. And then thank you to everyone else as well. And especially Pete for waking up really bloody early in the morning. So yeah, thank you. Let's give a round of applause to the panelists. And if you have questions, feel free to join us at the mics.
You guys mentioned it in your discussion just now. Hong said that hybrid. You said something about hybrid is the problem, one of the big problems to solve, and it's here to stay. You know, because working from home is here to stay, and yet being in person like this is, irreplaceable. So, just a quick note: a lot of us were, and partly because Sal recommended that we try AltSpace VR for AVAR 2020, which we did. And for all of those of you who participated in that, for me, it was earth-shatteringly profound in that the difference between a Zoom call and being in AltSpace was night and day. And most of us, or many of us, participated not with the VR headsets, but just with a flat screen, just as you were saying, Paul, I think is. And so the question I have for you is, the distinction was that the audio was simple, as I understand it, was simple panning and attenuation. So if I turn this way, you're in my ear, in AltSpace with my goofy avatar. So we were in the simulacrum of Digipen. Remember, we had the lobby. One of our students built the lobby in there. We're in AltSpace, so we're standing around in a room, and with our goofy avatars. And I turn, and it's panning. And then if I step away, it's attenuation. And that's not spatial audio, nearly what we're talking about at this conference, but it was more than enough to completely distinguish the experience from a Zoom call. And so the perfect being the enemy of the good, or not being the enemy, whatever, what do you see about a simple solution of just panning and attenuation to get us into some kind of hybrid reality that would work?
That's absolutely the case. That's how, there's going to be some announcement from Microsoft, so stay tuned. I'm not in a position to comment in more details. That's absolutely the first step to that kind of solution. And what I refer to as hybrid is we are always going to be people who want to meet in person in the conference room, and we are facing it today at Microsoft. Some people came in and some people are calling in, and how we are going to transfer that kind of have everybody have that kind of experience of not just speaking to a tile and the kind of experience that you're referring to in the VR. So that is a big challenge, an exciting challenge, actually.
Thank you.
Hey guys, thank you so much for the talk. Really enjoyed everybody's perspective. Karlheinz, same with you. Love interoperability. Like, it's better when we share and collaborate together, I feel. My question is I work fully remote. And so for me, one of the biggest challenges is dealing with the aspects of latency, both from a technical aspect as well as feeling like I have the right kind of space, that I'm not interrupting my colleagues, but I'm also still feeling like I can have an opportunity to chime in and still feel that there's some mechanism of feedback between me and them, which I feel like, Hong, as you brought up music, I feel like feedback, I'm a musician as well, so feedback with the audience is like a really crucial component. I'm curious how, if any of you have thought about ways through enhanced tech, like through audio effects, through UI, through AI, ways of mitigating the cognitive burden of latency.
We will be in a project next year where this is part of the topic, but I'm not that optimistic because there are some physical limitations. And of course, people have thought about prediction to mitigate these effects. I've heard from the people in Stanford who worked a lot of jointly doing music, that yes, they go with everything they can do to cut down on latency for the transmission part, but the basic problem will still be around. And if you want to get somebody from Australia in, no luck. You know what the speed of light is.
So
yeah, totally.
Go ahead, Pete.
This is exactly what I'm talking about, by the way.
The form of demonstration of the problem. Yeah. I think latency is a huge piece, and I think like there is just fundamentally a different dynamic to how we communicate, because just with audio in general, to get good quality signal out of sort of pretty average quality microphones is difficult. And if you've got a tune, like if you've got ASIO drivers and a half decent microphone and everything's like designed for like music production, you can get really low latency for self-monitoring locally. And if you had that and other pieces, you can experience what low latency telecommunications is like, and it's transformative. But delivering that on consumer hardware is pretty difficult at this point. But there is this different dynamic, and it's this kind of turn taking. And I think like around 150 milliseconds end to end is kind of the sweet spot that people aim for like natural turn taking without sort of stepping over each other. But even that's very difficult to achieve, especially, internationally as well. So yeah, latency is just a really, really huge piece.
I'd like to be way below 50 milliseconds, in fact, for communications.
Yeah, being a telecommunication engineer, the biggest problem is the network itself, and particularly the edge network, and particularly people's home Wi-Fi networks. And so innovations, which there are innovations in that space to get better control over delay. So that's really where that work has to happen, I believe.
Yes, so it's really important for us to look into this. So if you break down the latency, where does it occur? Network is actually, believe it or not, very small part of the latency. A lot of them happens in pre-processing, echo cancellation, noise suppression, pretty soon codec and everything adds to the piece. And then we have to deal with network quality, not network delay. So we need to deal with the packets not arriving on time. So that buffering is actually a big chunk of the delay. So we're looking very critically at each part. We're trying to reduce the delay. And I think there's definitely room for that reduction. And 150 millisecond, that number came from many decades ago when people studied telephone. Now, is that still a good number, right? So that's why I asked Meta the question, when you are experimenting with a 16 millisecond, did you try what it's like at 20 millisecond, 50 millisecond? So we're all pulling out numbers from thin air, 50 millisecond. We don't have a lot of evidence. So that is, I think that work needs to happen. On the other hand, there are also other cues we need to explore. Because in the room, if I want to interrupt, maybe I kind of sit up a little bit, or you look at my face, you feel like, okay, I want to say something. So that is also very important, how to communicate that online. And we do have video, but is video alone enough? can we communicate in a data channel or in some kind of a communicate that sense of your intention to interrupt? I think that's also a space for innovation.
Yep. Thank you guys so much.
Hi, first I just wanted to make an observation that some of the tools we use have become pretty good at masking the video background, so we can blur the backgrounds. I think we need a bit of attention to the audio because you can still often tell that someone's in a bathroom. But the question is kind of linked to this point, not just about latency, but many times we'll be joining these systems with no visual cues at all. We don't know that someone wants to talk. So what should we be emphasizing from an audio-only perspective to make this better?
Certainly, like, people unmute before they intend to speak, if they are polite enough to mute themselves. And there's other things that you do depending on like what device you're communicating with as well. So, I mean, we have microphones here. We would move closer to the mic. You would do the same if you're like just speaking at your laptop as well. Not true if you're wearing headphones that have like mics inbuilt with them. So, like, do we listen to the cue of taking a big breath in? What if they don't do that? It's coming down to like understanding like what is the human behavior in this circumstance and how do people actually perform when they're in these like environments and attempting to communicate with each other.
In fact, for me, this is less a problem of technology, which basically is around, but from psychology and people telling us how to modify user interfaces and what to do.
And we do modify our behavior for online meetings. There's a hand raise function you could click on if it's formal, kind of you want to say something. And regarding the bathroom situation, we do have a new speech enhancement based on machine learning that does reduce reverberant quite a bit, so that it does clean up your signal quite a bit, so that you are, and we're definitely thinking in the direction of, in a lot of video processing, there's like you could walk to a video camera and then the software will put on makeup for you so that you don't have to spend the time to, and there are, I'm envisioning in the future, there's going to be voice beautification, if my voice sounds really rough or I have a heavy accent that people are having trouble understanding me, and these are exciting futures, where we can explore, and that's going to be better than real.
Exciting or invasive? I don't know.
Yeah, I don't know whether I want.
You always have a choice. You always have the choice. You don't have to be,
Thanks.
So just to return to the topic of latency, there was obviously a few things you mentioned, like it's the edge network that's adding a lot of the latency or the majority of the jitters between the HMD and the Wi-Fi. So there's obviously things that we can do here to improve that, and I wonder if there's any hardware development or software development, such as integration of audio interfaces into HMDs, RJ45 connections for wired connections for HMDs, or a use of software development such as ultra-low latency compression codecs, Opus Fraunhofer ULD. Is there any developments here that we can do right now that you're integrating into the HMDs that people will use?
That goes to the HMD manufacturers, because as you mentioned, a lot of the technologies are there.
Yeah.
We do have low delay codecs and
to reduce the jitter buffers, it needs to be part of your Wi-Fi or your 4G, 5G connection as well. There's advances in 5G which allow more predictability on delay variation, which will reduce the jitter buffer sizes. So there's some hope there, and there's some advances on Wi-Fi.
For sure, but I guess the sort of majority of consumer home routers will be still on like Wi-Fi 5, so the sort of first mile jitter is terrible,
Yes.
So yeah, it's mainly wired connections. That's what I'm really looking for, I think.
Yeah, wired connections would be good.
Yeah, I think maybe to speak to that like, I think you're completely right. There is just so many pieces of the pipeline that need to be optimized and tuned. And yeah, I think that's just something that everyone across the industry is just realizing the importance of and moving as fast as they can with now. Because yeah, we really, latency, quality, all of these things, we really need to just get them to the next level to really unlock a better level of sort of social co-presence for VR and AR.
Hong, you touched on the non-native speaker issues. Similarly, for education, like under 12 years old, there's also a cognitive inability there that needs to be addressed. All of our discussions for the last 3 days have been touching on adult users. Is anyone working on education focus on AVAR for educations? I don't know, Google Classroom might have insight on this as well. Have people touched on this as well?
At the university in Ilmenau, we are working on the communication between the grandparents and the little ones. So that will include real experiments with these age groups, and we'll see what happens there.
Yeah, because one of our biggest impacts from the pandemic was with the kids. Like half of them excelled at working virtually, but then half of them just became total recluse mode behavior. So that was like a huge impact to that. So I'm wondering if anybody's working on that and encourage people to look further into that aspect of it.
Definitely, I think that's a really very interesting and very important area, and we do see some kids fall from A students to F students, and because of that, I think a lot of them is not certainly restricted to audio, to how the virtual space people can engage and kids can engage, and that's a really great area to explore. I don't think anybody has a ready answer at this time.
Yeah. Thank you.
This will be the last question. We do need to let people out of the room.
Okay, and then hopefully it's a decent question. So, I'm a loudspeaker engineer, so transducers are fascinating to me. And you guys are dancing around this topic in this whole discussion. And it strikes me, and with the panel that's here, it seems that the microphones and the loudspeakers or headphones are obviously a big part of it. And a lot of them had, as you said, there's echo cancellation built into the local devices. To me, it must seem that you guys desperately want that stuff all gone and centralize that. Now given this group, obviously in this area, is this something you're experimenting with and then wanting to look back to manufacturers and say, get rid of that or turn that off so that I can take control of this and maybe do a better job? Just a very open-ended question.
Yeah, we do have some issues where, say, we've got a virtual world or we've got an application which requires music to flow through the system. And then sometimes if someone joins on an endpoint which has got voice processing or some sort of processing built into the endpoint, it definitely can cause a problem. So I think there's many more use cases other than voice at the moment, so it's important to be able to take those into account right at the device level as well.
And definitely we want access to be able to program the firmware on the devices ourselves and switch on whatever properties we want and switch off the others and have additional software. And sure.
Yeah, Microsoft is a very kind of open system from that perspective. We do provide a core processing if you bring in a simple device that just does, its work. But if you believe that you have a better system because you know your device better, you're the speakerphone provider or your laptop provider, and you know your acoustics better than us because we deal with hundreds of or thousands of devices, but you deal with a few of your devices. If you can optimize stuff on your platform, we actually offload our processing so we don't double process and add all that distortion and latency. So I think from this perspective, we're not trying to tell the world, don't do anything, leave it to us. It's really a free kind of it's what's best for the end user. And end user experience is most important. So just go ahead and innovate your device or not to, so that your sound is pure, and leave it to us. So there's choices.
Pete, any last words? We're about to wrap.
No, I think that really captured it. Yeah. Yeah, there is just so much more to do on this. I think it's a really exciting space, and yeah, I think it's been a great group of people, and really interesting conversation.
Thank you. All right, everyone, you're free. Thank you so much again to the panelists for like the great conversation, and then hearty discussion over like the follow-up Q&A as well. I guess you guys can all go get coffee. We'll see you back in here or in the paper session. So thank you so much.
Thank you very much, Sally. And let's take a quick coffee break and be back here at 11:30. Thank you.